Hello, welcome back. This is Mrs. Skeen, and today we will be doing Equations Lesson 5. And this lesson is called Writing Equations from Word Problems. Our learning target for today is I can write and solve equations involving real-world problems. So in Equations Lesson 4, you wrote equations from sentences. This is going to get into more of those real-world problems that we could see. So let's look at our first example. A gray whale is 15 meters long. The fin whale is the length of both the killer whale and the gray whale combined. The length of a fin whale is 21 meters long. Write an equation to help you find the length of the killer whale. So, this one's been color-coded to kind of help us see what's going on here. Now, it tells us, right, that a gray whale is 15 meters. So they have chosen to put that in red. So we have 15 meters right there. That represents the gray whale. And it says a fin whale is the killer whale and the gray whale combined. So we know if we're going to combine them, right? That's a keyword. It tells us it's going to be an addition equation. And it says the killer whale and the gray whale. So we have the gray whale. Now it tells us we don't know, right? It says find the length of the killer whale. So we don't know that. So we're going to use an X because we don't know that. But we do know when we take the gray whale and the killer whale, it says that's going to give us the fin whale. So if we were going to put these all in letters, we could say, right, this is the gray whale plus the killer whale gives us the fin whale. So this is just really doing what would you do in real life to be able to figure out an equation that would get us and help us solve for that missing. Okay, so we're going to go through today and try lots of different examples. Um, and hopefully you will start to feel a little bit more comfortable with this. So let's look at the next one. Mount Rainier in Washington has a higher elevation than Mount Shasta, which has an elevation of 14,160 feet. The difference in elevation between Mount Rainier and Mount Shasta is 260 feet. Write an equation to help you find the elevation of Mount Rainier. So I sometimes like to think of this as, right, like drawing a picture. Think of a story. So it says Mount Rainier in Washington has a higher elevation than Mount Shasta. So I'm going to draw two mountains, right? Mount Rainier is higher than Mount Shasta. And we know it tells us right here, Mount Shasta has an elevation of 14,160. So I'm going to put that here. 14,160. The difference, ooh, that keyword difference, right? We've got this right here, tells us we're going to subtract. So from here to here, right? The difference in their heights is 260. And it says, write an equation to find Mount Rainier. So this is our missing. We don't know Mount Rainier. So think about this. If I knew, and I'm going to use an R for Mount Rainier, and I take away that 260, I'm going to be down here to Shasta, and I know what Shasta is, right? Mount Shasta is 14,160. So if you saw, right, drawing that picture a lot of times can help because it just helps us to get in our mind what is being talked about. Okay, and we found those keywords like difference. We found what we were missing. So you do what works for you, but sometimes just drawing a little sketch can be really helpful. All right, let's look at this one. Sarah is taller than her son. So let's right? Draw this out. We got 2 people. We've got, oh, so we have Sarah, and I'm going to put an S, and it says she is taller than her son. So here's her son. This one is the son. Her son is 2.5 feet tall. So we know the son right here. He's 2.5 feet tall. The difference between his height and Sarah's height is 3 feet taller. So, right, from Sarah to her son, we know is 3 feet. Write an equation to help you find Sarah's height in feet. Now, difference. What did difference mean? Subtract, right? So what would you do in life? We want to find Sarah's. So if we know Sarah's, what do we do to Sarah's? We subtract the 3 feet because that's the difference. And in the end, we are going to get down to that of her son. So again, that picture maybe helped you visualize and just thinking it through of what would it look like in real life, right? These are real world situations. So let's look at the next one. Joe goes to Applebee's. He orders a steak for $14. Then he pays the waitress a tip for X amount of dollars. His total bill, including the tip, is $20. Write an equation to represent this situation. Now, if you've noticed, right, we've had a number, a variable, an operation symbol, an equal sign, and what it equals. So when I do these, I like to get mine set up. Kind of like that one on Mount Rainier in Shasta. It had right? We know we're going to fill in these things, right? Now, do we know the end result? Yeah, because it tells us right here the total bill. That's what's going to happen at the very end is going to be 20. Then think about it in real life. He orders a steak for $14. So he knows he has to pay 14 no matter what. Then he pays the waitress a tip, but we don't know how much, so that happens next. So, what do we do to his steak and the tip to get the total? Oh, well, we would add them together, right? Okay, and in this case, hopefully you can kind of see how much would his tip be. Oh, he left a $6 tip, right? Because 14 plus 6 is 20. Well, we're not solving them for today. We're simply just writing. So our equation is $14 for the steak plus whatever he leaves for a tip has to equal 20. Later on, we'll get into where we are actually solving these. Okay, let's look at our next one. Susie ran a race. She ran 5 miles per hour. The race took her a long time to run. But T represent the time she spent running. She ran a total of 20 miles. Write an equation to help you solve the problem. So again, I like to get it set up. I like to get my blank, my equals blank. So right here, let me kind of, this right here, right? I'm going to put this yellow under it. That's our end result always. Do we know the end result? Yep, right here. This is her end result. She ran a total of 20 miles. So we're going to put that there. Now, it says she ran 5 miles per hour. So what does that mean? Oh, every hour she runs 5 miles. So with 5 miles per hour, and what are we missing? It says T. We don't know the time it took her to get to that 20 miles. So, but I do know, right, that it took 5 miles per hour. So 5 miles for every hour. And T is going to represent that hours, those times. Now, because it's 5 for every hour, what type of symbol are we going to need here? Do we get to take 5 plus the time? No, right? We're not going to subtract it. We're not going to split it up. So in this case, we're actually going to multiply. Now, as a sixth grader, we've talked about this before. When it's multiply, we just write the coefficient and the variable right next to each other. So if we were to solve this, right, 5 miles per hour, how many hours would she have to run to get to 20? Well, hopefully our math facts tell us that it's 4, right? Because 5 times 4 is 20. Okay, let's try a few more together, and then there'll be some that you can try and then check. So, Alyssa wants to celebrate her birthday by going to a play. She has a total of $45 to buy tea tickets. Each ticket costs $5. Choose the equation that represents the situation. So, let's get it set up, and then we'll find which one matches what we have. So, do we know the end result? Right? Do we know what we're going to put right here? We want the end result or the total. And I do. I know what she wants to spend. It says she wants to spend $45. So I'm going to put a 45 right here. Now, anytime I see like per hour or for every or each, that is a good sign that my equation is going to be a multiplication, because I'm going to do $5, it says, and my missing it gave me right here was T. Now, it's $5 for every single one of those. If I buy 2, 5 times 2. If I buy 3, 5 times 3, right? So this is going to be a multiplication. So in sixth grade, right, we go $5 for every ticket or for each ticket, and she has an end result or can get to 45. So if we look, any of them have that? Oh, C. It's flipped, but it still has, right? It's going to equal 45, and it's 5t. Okay, let's try another one. Becky is saving to buy a new truck. She needs to have X amount of money in her bank account. She sold her truck for $8,700. The new truck costs $45,250. Write an equation to help you find out how much money Becky needs to save to buy the new truck. So let's get our, right? We know every equation has the same similar format. Now, do I know the end result? Yeah, right here, right? My new truck is going to cost $45,250. That's how much money I got to have to buy that truck. Now, let's think about this in real life. What does she already have? Well, it tells us she sold her truck and has 8,700. So I'm going to put that right here. That's what she has. 8,700. And what are we missing? It says we're going to use an X. Write an equation to help you find how much money she needs to save. So what would you do with the money she already has and what she has to save in order to get this end result? Oh, well, we'd combine them, right? What you have right now plus what you save is going to get what she needs to buy the truck. So if we rewrite this nicely, we have 8,700 of what she already has plus how much she needs to save is going to give her enough to buy that truck. Okay, during the basketball season, Cord scored 43 points. He scored 5 fewer points than Lou. Write an equation to determine how many points Lou scored. So let's get things set up. Okay. Do we know Cord's end result? Yeah, we do. Right? We know the total Cord scored. He scored 43 points during his basketball season. Now, he scored 5 fewer points. So, fewer. Oh, fewer means, right, 5 less than Lou. But do we know how many Lou scored? Nope. So that's our missing, right? Let's put our X for Lou. We don't know how many he scored. But whatever he scored, Cord scored 5 fewer. So we got to take 5 away to get to the end result of Cord. Right? So again, hopefully you're seeing this really isn't that hard. We just think about life, right? We have X is what Lou scored. We take 5 away, right? Because it's 5 fewer to get what Cord scored. All right, let's do one more together and then we'll give you some to practice. So Mrs. Smith and Mrs. Nelson bought 73 books together. Mrs. Smith bought 24 books. Write an equation to help you find how many books Mrs. Nelson bought. So let's get it set up. So I always like to start with that end result, right? Do we know the total books they bought? Well, we do. It says they bought 73 books together. So I know that's my end result. Okay, and now I got 2 things. I got Mrs. Smith and Mrs. Nelson. Do I know one of them? Yep. Mrs. Smith bought 24. Now, do I know how many books Mrs. Nelson bought right here? Nope, because that's asking me to find that. So that's my missing. I'm going to put my X for Mrs. Nelson. Now, what would I do to Mrs. Smith's books and Mrs. Nelson's books to get their total? Well, you'd combine them, right? You'd add them together. So my equation is 24 plus X is a total of 73 books, and X is going to represent however many Mrs. Nelson bought. Okay. You try this one. When you have wrote your equation, go ahead and press play again and check your answer. Okay, Paige is planning a birthday party or a birthday dinner. She is going to serve a hamburger to each guest. A hamburger with all the fixings costs $4.25. She wants her bill to total exactly $68. Write an equation to help you find how many guests she can invite. So get set up again. All right. Do we know her end result? But the total she wants to spend. Yep, it says right here, right? She wants her bill to total $68. Now, what do we know? She's gonna, ooh, there's a keyword. She's gonna serve them to each guest. So for every single person, their hamburger is gonna cost 400. That would be an expensive hamburger. How about $4.25? Now, what are we missing? Write an equation to help you find how many guests. So let's put a G to stand for guests this time. It doesn't really matter what variable. We could have just kept using X. Let's use a G to mix it up. So 425 for each guest. Do you remember we said if we're going to do it for every one of them, right? We're going to multiply. So we have $4.25 for every guest. And she wants to spend a total of $68. All right, try this one. When you are done, go ahead and press play and check your work. Okay, hopefully you have tried that. Let's go through it. Miss Trunchbull, ooh, a little Matilda reference, orders the head cook to bake a cake. The recipe calls for 7 cups of flour. Cher already put in 2 cups. Write an equation to help you find how many more cups she will need. Okay, hopefully you started off by setting everything up and asking yourself, do I know my end result? Yep, to make this cake, the result is I need 7 cups of flour. Now we think about in life. It says she already put in 2. Write an equation to help you find out how many more cups she's going to need. So here's what she's going to need. So what would you do to what I have and what I need to get that total of 7? Oh, well, real life would tell me I would add the flour I already have and the flour I need to get my total. So hopefully the equation you found was 2 plus 6 equals 7. All right, read through this one and try it and pause and work it out and then press play when you're ready. Okay, let's go through it. Write an equation to help you answer the question. How many Blu-rays can you buy with $110 if each Blu-ray costs exactly 11? So we've got it set up. Do I know my end result? How much can I spend on Blu-rays, does it say? Oh, I can spend 110. I found a keyword again. Each Blu-ray is 11. So I know it's $11 for every Blu-ray. And remember, if I'm going to do it for each, I'm going to multiply. And then there's my, how many Blu-rays can I buy? I don't know. I got to figure that out. So my equation, wrote nicely, is 11x equals 110. Now, hopefully mental math right here, right? If you know your 11 times tables, you can figure out really quickly how many they can buy, right? Because 11 times 10 is 110. Okay, a couple more. Go ahead and work out that one. Plus play when you're ready. Okay, let's go through this. Let's get our set up. Mrs. Bryan is buying notebooks for her students. She spends $54 on N notebooks, right? We don't know how many she bought, but she spent $54. We know that each, we're starting to see that word a lot, notebook costs $3.25. Select the equation that represents this situation. So, do I know her end result, what she spent total? Yep, $54. I know that each notebook costs $3.25. Those are some hopefully nice notebooks. That's kind of expensive. So $3.25 for N notebooks is 54, and because it's for each or for every single notebook I have to pay $3.25, I know that is a multiplication equation, right? And I write it nicely with the coefficient and then the variable. So if we look at our multiple choice, is there one of those that it matches? Yep, matches A. Okay, let's look at this one actually together. This is a little bit different than some of the previous ones that we have done. So after eating at a restaurant, Olivia, Lexi, and Kate decided to split the bill evenly. If each person paid $13, what was the total of the bill? Write an equation to help you solve the problem. So let's go ahead and get our formatting set up. Now, in math, if we're going to split something, right, we know that's going to be a division. We're going to split something up. In this case, they're splitting the bill. So if we go eat at a restaurant, right, we have finished eating. What happens next, right? Oh, they bring us the bill. Now, do we know the total bill? Nope, that's what we're missing, right? So I'm going to put that first because we don't know the total bill. But whatever the total bill is, we are splitting, right? We're dividing. And who are we dividing it by? Well, we have Olivia, Lexi, and Kate are all dividing that bill. So we're going to split the total between those 3 people. And our end result, right, is that we all had to pay $13. Now, a lot of times we're going to, in 6th grade and beyond, see this wrote in that type of formatting. Okay, but again, we just thought about this, right? In real life, after we got done eating, they brought us our total bill. We don't know what it is, but then we're going to split that between 3 people. And in the end, we know we each have to pay $13. Okay, go ahead and try this one. And when you're done, press play and we'll go over it. Okay, let's talk about this problem. So let's again, after paying $7 for a pie, Shaden has $62 left. Write an equation to help you represent how much money he started with. So we've got our formatting set up. Now, after paying $7 for a pie, if I have to pay $7, I'm going to subtract 7 from what I have, right? And then it says Shaden has $62 left. So I know that 62 is going to go here because that's what happens in the end. In the end, he still has $62. Now, write an equation to help you represent how much money he started with. We don't know how much he started with, but we're going to put an X, right? And we know that's going to go at the beginning because that's the first thing, right? You start with some money. And then what did he do? He had to pay, so he had to subtract 7. And now he has $62. So X minus 7 equals 62. Hopefully that's what you got. Okay, pause and try this one, and then we'll go over it. Okay, last month Forrest had $24.50. He put up flags for Veterans Day, and he now has $85.75. Write an equation to help you find how much money he made while putting up flags. So do we know his end result? Yeah, it says he now has, right? That's going to be what his end result, what he now has is $85.75. Now, last month he had $24.50. So that's what he's starting with, right? He has $24.50. Sorry, it's not writing very well. $24.50. And he put up, or he made some money, but we don't know how much he made. That's what they want us to find out. So what are we going to do with the money he had last month and the money he made to get his total? Well, we're going to combine those, right? We're going to add those. So our equation is 24.50 that he had last month plus the money he made gives him a total now of $85.75. Okay, so that's it for today. Again, we're going to continue working on this in lessons to come. We'll be solving them and stuff, but hopefully today you understand how to set up an equation based on a real world situation that you may be given. So, all right, have a great day.